So the OCP was a sponsor of the Chiplet Summit, and we closed with a keynote where we had an overview of the OCP's efforts into creating the components of a new chiplet economy. And the talk as a whole sort of outlined the requirements for what we see as the parts of a chiplet economy, and the idea that you need that there's a whole bunch of things you need to make chiplets work. The idea that you need support for business workflows with chiplets, that you need support for technical workflows, because the way business gets done with chiplets and the way information gets exchanged with chiplets is different, and that you also need a lot of building and reference implementations so that the community can take away from that. And finally, of course, the thing that everybody talks about, which is the idea of defining open interfaces for chiplets. So our talk here at the summit overviewed our general approach to what we think. The foundational idea here is that chiplets are going to be everywhere chips are, and that everywhere chips are serves a fantastic wide range of requirements. And so to meet those, you probably need a diverse approach. And the right way to do that is to create an infrastructure rather than being too prescriptive, a set of open standards. And what we hope to do is learn from the way, say, Linux did it, where you release an open standard and everybody takes that and adapts it to their own requirements. And that's generally our approach in the OCP, is to create an infrastructure of standards, materials, prototypes that the community can go and use and adapt to their particular needs. In terms of the development since the last time we met, the biggest one is the release of a spec called CDXML, which helps you describe chips. So think of it as an electronic data sheet. And the even bigger news is that the OCP is going to join forces with JEDEC and develop this jointly. So now this is going to become part of what's called the JEP 30 part model. And this is thanks to some fantastic volunteering work from our CDXML group with Jawad Nazrullah, David Rachkoff, and James Wong and Tony Mastriani from Siemens Mentor, who spearheaded this charge. And thanks to this, every JEDEC part will soon have a CDXML description which is fully consistent with the OCP spec. So this is going to be a key component of our technical workflow in terms of if you're going to do a design space exploration, if two stages in the value chain are going to exchange electronic information about parts, or if you're even going to search a chiplet catalog, you can do so electronically instead of relying on a data sheet. And this JEDEC part model, this CDXML model should go a long way to making that happen. And that is the biggest change. And going forward, we are going to continue to build an open package, release the next version of the BOW specification, and release a link layer specification as well. The other incredibly exciting news to share is that we actually have companies who implemented the BOW protocol, bunch of wires protocol that the OCP released in silicon, and have demonstrated line speeds of 16 gigabits per second. And it's working. It's in the demo hall here. We've got two companies which have announced silicon that meets spec, and on top of that, in some cases, the actual power the interface consumes is less than what is required by the standard. So it's fantastic news in that we're getting the first few proof points in AI, in networking, and other use cases for BOW silicon.